Hello and welcome to another lesson. In our last video, we looked at the differences between theoretical and experimental probability. Theoretical being what we expected to occur, and then experimental being what actually occurred. And what we found in a couple experiments is that our theoretical and our experimental probabilities didn't match. And in some cases, they weren't very close at all. So today we're going to look at the law of large numbers, which helps us to make a little bit more sense about those differences between the theoretical and experimental and how we can get a little bit closer. So the law of large numbers is a way to describe that difference between theoretical and experimental. And it was first developed back in the 1700s by Jacob Bernoulli. And since then, his work has been improved upon, but he came up with that first basic premise, which was that the more times you do an experiment, the closer that the theoretical value will be to the experimental value. So when he found, after doing an experiment thousands of times, he was able to get the theoretical probability and the experimental probability to be about 1 to 2% away from each other, which is a lot closer if we had only done, let's say, 10 trials. So today we're going to take a look at this law in action, and we're going to use a spinner to see how close we can get those probabilities together. Okay, so here I have a spinner, and on my spinner I have 5 sections, and each of those sections is the exact same size, so they all have the same probability of being spun on the wheel, which is 20%. So what we would expect is that 20% of the time we would get each of these colors. So now let's go ahead and start with a low number of trials. Let's start with 10 and see if that experimental probability is close to what we expected with the theoretical. Okay, so that was after 10 trials. And looking at it, I have vastly different experimental probabilities. Blue was at 0%, which is nowhere close to what we expected with 20. Yellow's a little bit high, cyan is low, red is spot on, but they should all have the same experimental probability to match that theoretical. And then purple is also about double what it should have been. So with 10 trials, we have a large margin of error here. So now let's increase it to 100. Let's see what happens after 100 spins. And we're not going to sit here and watch it spin 100 times, so I'm going to go ahead and jump to the end and see what happened. Okay, so here we're a little bit closer. For blue, I'm at 18%, which is almost spot on. So 18% of those rolls. We also have some higher values with red still, and we're not exactly there with the theoretical. So even 100 trials wasn't enough to make those probabilities match up. So now let's try 1,000 and see what it looks like. And again, I'm going to skip to the end because we're not going to watch 1,000 spins. Okay, look at those probabilities. Look how close they are. Each of them, each of the colors is within 1 to 2% of the theoretical value that we were looking for here. So again, that law of large numbers, the more trials we do, the closer this experimental value is going to be to the theoretical value. I encourage you guys to check out the law of large numbers at home. A good way to do it is using a die or a number cube. On a number cube, each number has an even chance of being rolled. So you have that 1 out of 6 probability. So pick a target number. Let's say you pick 4. Roll that die 100 times and see how many times you get 4. And hopefully your experimental probability will be really close to that theoretical and you'll get 1/6 or something close to it. If not, keep rolling. Try 1,000 times. And if you don't feel like rolling a number cube 1,000 times, there are a lot of random generators out there online, just like my spinner tool that I used, that will do the work for you. Have fun experimenting, guys, and I'll see you in the next lesson.